Good morning. I hope everybody had a great weekend. It looks like we're going to be here through the end of the semester for sure. So um, I'm glad you're returning back to FS 330 this sunny Monday morning. So just some announcements to get us started. What I'm going to start doing from this point forward is giving you this week's assignments as well as summing up the remaining assignments for the semester, just so we kind of know what we have ahead of us, because really we have about a month left of class. So this week you have one homework due, and that's Quick Breads. It opens this Wednesday and is due on Friday, April 3rd by 11:59 p.m. And remaining for this semester, we have one first exposure quiz about breads. So when we get to yeast breads, that's what that's about. And two more homeworks, steam leaven products and yeast leaven products. Our remaining baking labs and sections are broken up based on the type of leavening that is utilized in these products, and we'll talk more about that today. So those are your three remaining assignments. We do have some extra credit that's coming up as well, and that'll be available to you that last week of the semester, the week of April 20th. There's one homework. We will talk a little bit about chocolate and ice cream, and there's one homework associated with that. In order to help you sort of get ready for the final exam, this homework is not a required homework because it is the last week, but if you do complete it, you can get up to 3 points extra credit for that. That will be added on to your lowest exam grade. It can be 1 or 2, exam 1 or 2, whichever one's the lowest. Those points that you earn through the homework for chocolate will be added to it. The same thing is true about our virtual NC State Dairy Tour. So typically what we would normally do is have a real life NC State Dairy Tour where you can see where they make milk and ice cream, but that's not possible right now. The dairy is actually running because the cows don't stop producing milk, so they are considered essential. They are still running, but we do have a really great virtual tour that you can watch. So that link is in Moodle, and basically you'll write a 250-word summary about that tour, what you learned from it, what you enjoyed about it, things that were unexpected that surprised you. Write that 250-word summary and submit it, and that'll get you 3 points again to your lowest exam grade, either exam 1 or exam 2. So that's a total of 6 points extra credit that could be added to an exam grade. Both of those are due that Friday, the last week of class. So keep that in mind. So those are both options for you. I wanted to give you a little heads up about the final. I like to start talking about it early just so everybody has it in their head, really locked in there about what's going on with it. Typically, this would also be an in-person exam, but now we've moved everything to online. And so this will be structured very similar to exam 2. It will be online. It will be open note, open book. So feel free to do that. Again, not collaborative. So this is your work and your work only. We shouldn't be talking about questions on the exam until the exam has officially closed. It will open Wednesday, April 29th. So that's Wednesday after classes finish, and is due Friday, May 1st at 11:59 p.m. Again, your grade will not automatically be there in Moodle because it does have to be manually graded, even though it is given on Moodle. So be patient with that. The test composition is a little bit different. So this test is very comprehensive. But it does include new material. So the test itself will be about 40% of the exam will be the new material. So that's everything since fruits and vegetables. That'll include dairy and then all of the baking labs that we are getting ready to start. So dairy through all of the labs that utilize flour, quick breads, chemical leavening, steamed loaves, or steam leavening, and then yeast leavening as well. So those 3 units in dairy will be included. Oh, and chocolate and ice cream. There's just so much excitement, so much to do. For the comprehensive portion, the 40% of the exam that's new material will be structured just like exam 1 and 2. The 60% of the final that will be comprehensive questions, that will be a total of 5 comprehensive questions with multiple parts like we typically have. But you get to choose which 3 you would like to complete. So it'll be set up in Moodle the same way as exam 2 was. You just select which 3 questions you want to do. This is not an opportunity to answer all 5 and then I pick the highest grade. What it is if you do answer all 5, I will only grade the first 3. So I'm only grading 3 questions for you no matter what. So make sure that you don't have answers entered in Moodle for these other questions, okay? And it will be twice the amount of normal time. So typically we give 3 hours for an exam that's in person. This will be 6 hours will be allotted. So give you just a little bit more time on that. So hopefully that's pretty clear. If you have questions about the remaining things in the semester assignment-wise, extra credit, or the comprehensive final exam, then we can talk about them Wednesday during our Zoom meeting. Hopefully we'll be able to do that. I did have a snafu technically with the Zoom meeting from last week. It was not recorded. So hopefully this week, I think I've got all that worked out. Hopefully this week we will have the meeting recorded and then it'll be posted on Moodle. So still trying to work out some of those technical difficulties on my end. I do apologize. All right, so let's jump into baking. As I've said numerous times, this is some of my favorite lecture material and favorite lab material. I find it very interesting. There's a ton of chemistry involved in baking, so we'll be diving into that right away. So you may have done this type of science fair project in elementary school. This is a volcanic eruption simulation that a lot of students used to choose for their science fair projects. It's probably super outdated. But what in the world does this type of volcanic eruption have to do with baking, right? Well, let's see. First of all, before we jump into that particular question, let's give us some context about what leavening is. Leavening is basically aerating a baked good and creating pockets of space or air in that particular product. With this pound cake, you can see there is some texture to it and there's little pockets of air. Some of them are quite tiny. You can't even discern them on this picture. With the Genoese sponge cake here, you can see the pockets of air are much larger. There's not quite an even distribution throughout it, but they're all pretty small. This texture, or the amount of air and the size of the air pocket and the range of sizes of the air pockets, is referred to the crumb in baked goods, right? So this pound cake has a very tight crumb, meaning that the air pockets are really small, very small. So this product is much more dense in texture than this product, the sponge cake, where you have a much more open structure and a lighter crumb, okay? So that's leavening when we're talking about adding air to a baked good. And we can do that in a variety of ways. One way is chemical leavening, where we're mixing acids and bases. So you may be thinking about this volcano now, because our volcano is mixing of acid and base to generate CO2, and it's this big explosion of foam that erupts out of the volcano when you mix the two together. The same thing is happening in your baked good. When you mix an acid and a base, you get evolution of CO2 or carbon dioxide, and that helps leaven the product. We can mechanically leaven the product, and this is done with mixing. All of our meringues are lighter because of mechanical leavening, right? We're whipping a product to increase the amount of air contained within it to make a foam. So mechanical leavening is not only utilized in making meringues, but it's also used in things like pound cakes, or not pound cakes, angel food cakes. Very much the same shape, but different product entirely. So angel food cakes start off with whipping of egg whites to create a meringue, and then you fold in sugar and flour. So this is a very light, airy product. All of that mechanical energy that went in to make the product is the leavening of it. Steam is another method. If we think of something like a croissant that's very open in structure, or a cream puff, or eclair, those things utilize steam in creating open, leavened structure, right? Yeast fermentation is another one. Now, this is probably the most time-intensive of the 4 types of leavening, because you do have to let the yeast grow consume whatever carbohydrate sugar is there and produce CO2. But it has so many benefits of letting this happen. So that's the last type. All of these, except for chemical leavening and yeast fermentation, are both utilizing CO2. Mechanical and steam. Steam is obviously utilizing water vapor, and mechanical is just air. So we may be using a different gas to create this leavening, but the end product the goal is always the same, to create pockets of air in the finished product and lighten the texture. Oftentimes, these different types of leavening can be utilized together, and we'll discuss that here. Chemical leavening and mechanical leavening are often used in products like cakes. So for chemical leavening, it's all about carbon dioxide. How much are we forming and how are we forming it? When is it formed in the process from making a batter and then moving through to your end product through baking and removing it from the oven and allowing it to cool, because your product is never done until it's completely cooled. Oftentimes that is the case, especially with baked goods. The texture continues to change right from the initial start of baking all the way through till it's cooled to room temperature. So chemical leavening is just acid-base chemistry. We're mixing an acid with a base and we get carbon dioxide. So where are these acids and bases coming from in our baking? There's two main sources of acids and bases that we use. Baking powder is one ingredient that is often added to quick breads. And quick breads are called that because they are quick in comparison to things like yeast breads, which take time for that fermentation to happen. So anything where we're using a chemical leavener is typically referred to as a quick bread, like cookies and brownies, banana bread, pancakes, waffles, all of those types of things fall into this quick bread category. So we can use baking powder, which when you're adding the baking powder to the product, this contains both the acid and the base. Okay, so both of those things are in baking powder. When you add baking soda to a product, this is sodium bicarbonate, and this is only a base. So baking soda is just the base. You have to have some kind of acid that's already present in the recipe in order to react with it and create CO2. If you don't have an acid from an ingredient in your baked product, then you're just adding base in, and it's going to make the product taste metallic. Some people refer to it as bitter. Excuse me, as bitter. So we can use baking soda as long as there is some type of acid in the product. Most baking powder that's on the market is referred to as double-acting baking powder. And it's referred to as double-acting because you have one portion of acid that solubilizes when the product is mixed with liquid water, right? And so initially you get an immediate reaction between the acid and the base, and you have CO2 formation. The second act of the baking powder is done in the oven. So there are different types of acids that are only solubilized with heating in water. So these acids, once the product goes in the oven or experiences some kind of heat, like on the griddle with pancake, those acids are then solubilized, and the acid and the base react with each other, and you get leavening a second time, right? So here we can see there are different acids that can all be added. And then over here in this table, it shows you after 2 minutes of mixing how much CO2 has evolved from that particular acid-base reaction. And then once it sits on the bench for 10 or 15 minutes, how much acid has evolved. And then finally during baking, how much CO2 is released there. So you have some things like cream of tartar here, so tartaric acid, where we get most of the CO2 formation by reacting with baking soda. So if you just took cream of tartar and mixed it with baking soda, 70% of that CO2 that evolves from this reaction, one-to-one reaction here, is going to be done on mixing. So the majority of the CO2 is released with mixing. And then during baking, you get about 30% release. release. So a little bit of heat does help solubilize some of that cream of tartar. On the other hand, you can have a product such as a sodium aluminum phosphate that has very little CO2 evolution when mixing, but once we get to baking, 70% of that CO2 is released. Now, why is that important? Why does it even matter that we have these two different releases of CO2? Part of this has to do with the baking process. When you bake something, you have a lot of different reactions going on. We can have starch gelatinization, protein denaturation, fat melting, air expansion, right? There's lots of things going on. And one of the things that's happening is evaporation. So evaporation on the surface creates this hard, rigid crust. Now, if we had all of the CO2 released after that crust formed, then we wouldn't have any more expansion. The product is basically locked in space or locked in its shape. And then if you had additional expansion, you'd probably have some type of bubbling out of a crack within that crust. So where all of these different types of reactions happen is really important. If they all happen right at mixing, if you release CO2 right at mixing and you let it sit on the bench for 10 or 15 minutes, all of those bubbles of CO2 are going to dissipate. And so you still have a very dense product, right? But if we have most of our CO2 evolving here during baking, before the crust forms, then we'll get a very light product. Now, different products require different things. And so these are all used industrially as different types of baking soda. Pretty much you don't go to the grocery store and find a selection of 15 different baking powders to use for different recipes, right? We have one standard baking powder. And very often what we're using is sodium pyrophosphate here, where we have a little bench release and a lot during baking. Now, if you think of the process of making pancakes where we're mixing them up and then it takes a while to bake all of them, this is exactly what you're looking for. You want a lot of that CO2 to evolve during the baking process, because if it all evolved after you mixed it, by the time you got to the baking process, they'd be pretty flat pancakes. So hopefully that helps. One other thing I wanted to mention is that if you have a recipe that has an acid in it already, so let's say you're making pancakes and you use buttermilk. Buttermilk is an acidic dairy product, right? So it has acid in it already. If you did that, then and you just use baking powder, all of the baking powder, the base that's in that baking powder would react before you got to this acid release because of heating. Okay, so think about that for a minute. We have our flour mixture, we add in baking powder, and we add in the acid from the buttermilk. So initially, that amount that reacts, from the baking powder acid that reacts, let's say we're using the sodium acid pyrophosphate, that 28% that reacts at the bench will react with the base. Now, there's enough base in baking powder left to react with the part of the sodium acid pyrophosphate that is solubilized during baking. However, you've added another acid. You've added the buttermilk, right? So there's that acid component there. So the base that's in the baking powder is just going to go ahead and react with the acid in the buttermilk, and then you'll have very little CO2 release during baking because all of that acid that is solubilized with heating, it has nothing to react with. All of the baking soda has already reacted with the buttermilk. So oftentimes in this case, what we're doing and what you see in recipes is an addition of baking powder and an addition of baking soda. So what you're doing is balancing out the baking or the acid that's added as an ingredient by adding in baking soda. So then there's baking soda left over to react with the acid that's solubilized during baking. Ooh, obviously hungry this morning. So that's what we have. Really, we're trying to make the seesaw of acid and base concentration even, right? So if we have an acid ingredient we're raising the amount of acid and the base just stays right here. But when we add the remaining baking soda, now we're bringing it up so that it's even again. Okay, so that's what we're looking for. I did want to talk for a few minutes about protein in flour. In quick breads, we often don't think about the protein in flour being very important, but it really is. We're trying to do something different with this protein in flour than we're trying to do with something like yeast bread. So let's talk about exactly what's going on. You've probably heard the word gluten numerous times, and you may or may not know what it is. Gluten is the word that we use for the protein in flour. Okay, so anytime you are taking dry flour, the proteins that you have are a range of different types of proteins in there. Just like we saw with egg whites, there are lots of different individual proteins that make up this large category of egg white proteins. So in flour, the two main proteins that are there are gliadins and glutenins. And these are names for big groups of proteins that are there. There's many different ones, but gliadins and glutenins are the proteins that are in flour, the two main groups. Now, in dry flour, that's how they exist. It's two different groups. But once you add water to flour, you immediately get these two protein groups, gliadin and glutenin, reacting together to form gluten. Okay? So gluten is the combination of gliadin and glutenin reacting with each other to form this network of proteins called gluten. That happens just upon adding water. All right. The second thing that you can do to even strengthen this protein network that's formed by gluten is kneading. So we can have a product that's just dry flour, gliadin, and glutenin. We add the water in, we get gluten, and then we knead the dough or add additional shear to it, right? So kneading it is pushing on it and moving it about and stretching it. You can do that in a machine or by hand. And once we've kneaded that dough, we get a much stronger gluten network. So when you add water just initially, you get gluten formation. That cannot be helped. That's just how this works. The more you stir it, the more you mix it, the more you knead it, the more strong that gluten network gets. And when we have a stronger gluten network, we get a tougher product. Think about a baguette. If you eat a baguette, this is a very chewy bread. You have to use a lot of chewing and mastication to get that product broken down. And if you think about something like a pound cake, this should be a very tender product. You shouldn't have to chew a whole lot. Or a pancake. You shouldn't have to chew that a whole lot, right? It shouldn't be hard where you really have to work to get your teeth through it. Right, so those are two different ends of the spectrum. But the more you work a particular flour product, the more shear you add to it, the stronger that gluten network is going to get. And that's what's important. So how do we control this gluten network? Well, one way we just mentioned is the amount of shear that we have there. The second way is the concentration of protein that we have, right? And what the quality of that protein is. So that was gone over just a little bit in your lesson with respect to the amount of ash in a flour product and the quality of that protein. When we talk about quality of protein here in this instance, what we're really talking about is how easy it is for that protein, the glutenin and the gliadin, to get together and make a really strong gluten network. That's what we talk about with quality. If you're talking about it from a nutritional standpoint, quality is the amount of digestibility and the type of amino acids there, or all the essential amino acids there. That's not what we mean in this case. When we're talking about quality, we're talking about the strength of the gluten network that can be formed from that protein. So protein concentration matters as well. There's lots of different types of flour. When you go to the store, you'll see bread flour, all-purpose flour, maybe not so much right now on the shelf. I think those distributors are still trying to catch up from all the demand. But they have lots of different types of flours. Now, some of these flours are made with soft wheat and some with hard wheat. Hard wheat typically conveys a stronger gluten network. So when we have things with these lower protein concentrations, and pastry and cake flour are those lower protein concentrations, typically those are made with softer wheat products. And they have lower protein concentrations, so 8% and 9%. And these are used for just what they are called, pastries or cakes. All-purpose flour, which is used for lots of different products. It's around 12% flour, and then bread flour is even higher, or 12% gluten, excuse me, 14% protein in bread flour, so it's even higher. And of course, bread flour is used for things where you want a really strong gluten network, like yeast breads. And down here in the middle is a product that is called biscuit flour. This is typically available in the South. If you were to, of the United States, if you were to go to New York, you would be hard pressed to find white lily flour up there because biscuits just aren't typically made up north. They're a very southern type of food product. And this has that in-between concentration as well. It's a little bit higher than pastry flour or cake flour. It's not quite all the way up to all-purpose flour. Biscuits are one of those things that require an intermediate gluten network to form. So you want to choose whether you want a very firm, strong gluten network or you want something very tender. You want to choose the type of flour you're using based on that desire, because the protein concentration matters. The more protein we have, the stronger the gluten network can be. There's more protein interactions, and so you get a stronger, more elastic, tougher end product. Right? So protein concentration can affect it. Choose wisely. There's also in your lesson, be sure to review that, how bleaching affects these different types of proteins, as well as the starch structure there. Bleaching is very typically used for cake flours. There's a couple other ways we can control the gluten network as well. And if you haven't figured out by now, in most cases for quick breads, we don't want a whole lot of gluten formation. We don't want a really tough pancake, right? That's kind of a negative. If you've ever made muffins and they come out really tough, it's not really desirable. We want those to be tender. Same thing for banana breads, for cookies and that type of thing. Very tender products is what we're looking for. So we want to prevent gluten formation. So one way we can do that is the amount of mixing or shear that we're adding into this dough or batter. So this is pancake batter here, and you can see the difference in the product between 1 stir, 10 strokes, and then 100 strokes. And so where you want to be is somewhere in this range, about 10 to 15 strokes to mix in the dry ingredients into the wet ingredients. Now, even though it's still lumpy, that's where we want to be, because if we use 100 strokes to get everything very homogeneous, no lumps, all the flour is mixed in perfectly, then we have a tough pancake. So you want to avoid that. The least amount of mixing you can do, the better off you are. These lumps will hydrate as they sit, as the batter sits and rests, as well as when it is being cooked as well. And one last way that we can control gluten is adding fat. So just like in everything else we've talked about where we're tenderizing a particular product, when we have a protein network, we add fat. Fat acts to disrupt networks, and it does it in different ways, where sometimes we're just physically disrupting that network, and other times we're actually using hydrophobic bonding. And in this case, we're using hydrophobic bonding in order to disrupt that gluten network and tenderize it a whole lot more. Where you'll really see this is when we get to yeast breads. When we're comparing something like a challah that has been heavily enriched with egg yolks and oil compared to a baguette that has no fat in it, or no added fat in it. So these two products create very, very different textures. So bottom line, if you're creating a quick bread, you want to mix it as little as possible. You just want to get those dry ingredients just barely incorporated, and this will help prevent gluten formation. So how do we make all this happen? We've got all this. How much mixing do we need to have proper gluten formation? We've got chemical leavening that's going on. What in the world? How do we get all this to come together into an end product? So there's several different types of mixing, and this week is fairly video intensive. So be aware of that. We have straight mixing is our most basic type of mixing. This is linked on the Moodle page, and you have another link here as well. I think these are two different types of videos, but don't let that alarm you. So straight mixing is when we're mixing the dry ingredients, we're mixing some wet ingredients, and then we take the wet ingredients and the dry ingredients and we mix them together. This is exactly what happens for pancakes and waffles. oftentimes for muffins. Sometimes this is called the muffin mixing method. So this typically can yield a pretty dense crumb if you don't have a lot of chemical leavening in there. So straight mixing, very basic, very simple. Creaming and batter formation. Now this one is used quite a bit with things like cakes and cookies. So creaming is when we take a solid fat and mix it with sugar. And there is a great video linked here. I think this is the same video as linked on Noodle. So when you mix the solid fat, now keep in mind this has to be solid fat. So if you're using butter, that's great. Shortening, it can't be an oil. All right, so we can't use canola oil or vegetable oil. This has to be solid fat. And then we're adding in sugar. So just 2 ingredients. So when we do that, and you may have seen this in recipes if you enjoy cooking, mix the butter and the sugar, and that's all it says. This is actually a very critical step, and I didn't really realize it until I really started researching for this class. What you're doing very often when you're creaming a product is adding mechanical leavening. So you've got a solid fat, and you're taking these sugar crystals and ramming them through the solid fat, and they leave this pocket of air behind them, right? So in the video, you'll actually see how the color of the butter and the sugar change as more and more air is whipped into this product. More and more little pockets of air are created by these sugar crystals digging out a trough through that solid fat during the mixing. Now, this is key if you're using a chemical leavener. So if you're adding baking powder or baking soda and an acidic ingredient, this is key. Those little pockets of air that are trapped in that fat, when the acid and the base react with each other and create CO2, that CO2 can enter that little pocket of air and expand it out. So now you've got almost like little seed pockets of foam that's there waiting to be expanded when CO2 is formed in your dough. So very often, creaming, a mechanical leavening method, and chemical leavening are used together. You'll see this in some of our recipes, particularly with brownies, and I believe the cookies recipes as well. So once you've got this creaming done, and this is typically the first step in a recipe that's mixed this way, you're going to add in your eggs, right? And our eggs contain the yolks, which have a lot of phospholipids, which have quite a bit of emulsifier in them. And so they emulsify that fat into the butter that's there into the recipe. And then you're going to alternate your liquid and any previously mixed dry ingredients like the flour, chemical leavener, salt, all of those things that are added in, any spices. So cream the butter and sugar, add in the eggs, mix them well, and then alternate liquid and dry ingredients. Usually you alternate about a third of the batter or a third of the flour, then half of the liquid, third of the flour, half of the liquid, third of the flour. That's pretty typical. This creates a very light crumb and really slows down baking as well, because all of that air that you've put into it with creaming is acting as an insulator. Okay? So anytime we have a lot of air, it doesn't conduct heat very well and acts as an insulator and slows down the baking process, allowing that chemical leavener to completely solubilize and the product not to spread quite as much. Sponge cake is another type of method that we will be using, and this is a great video on sponge cake. Sponge cake usually has a high ratio of eggs in it. You're relying quite a bit on eggs to create the structure. So this is a very light textured cake, but it also makes something that's very elastic, very spongy, where you press down on it and it will rebound. And you'll see them doing that in the video. They press down on the cooked cake and it rebounds right away. This is really great if you're looking to build quite a large cake with multiple layers, maybe multiple tiers. This type of cake really can hold up to that type of structure because it does have more rigidity. And it tends to be a bit more on the dry side. So it's not a very moist cake. Because of this high egg content, proteins bind water, as we've heard in the past, right? In our meats, we talked about proteins binding water. In this case for eggs, they're very water soluble. So they bind a lot of water, and that tends to convey a less moist cake. Oftentimes, their cakes are washed with some kind of glaze or syrup to combat that, to give it a little bit more moisture. So the way that this happens is you beat the whole eggs first, and you create a foam with the egg white and the egg yolk. And then you're going to fold in flour and then add melted butter. This is mechanical leavening at its best. Sometimes we, again, add chemical leavening to help expand out those air bubbles that have been created by mechanical leavening. All right, so take a gander at that video. It's a great way to learn how to make sponge cake. If you've never made it, I encourage you to do it if you have the ability to. It is a very interesting technique. So we've got just a few more minutes. So I'm going to go over the next couple of things because these are different types of leavening mechanisms. Rubbed doughs are another mechanism for this, and we are going to be utilizing this technique in lab with our scones and southern biscuits. So short rubbed doughs are textures like the scones, or next week's lab when we make the pâte brise crust dough. And this also talks a little bit about blind baking. And this is when we bake the pie crust prior to filling it, right? So we want the pie crust to not be filled while we're baking it. So this is a short rub dough texture. And what we're talking about when we say rub doughs is we're taking the dry ingredients and a solid cold fat. It's very important in this case that that fat is cold. And squashing it, rubbing it down. We call it a rub dough because often we're rubbing the fat between our fingers in the flour. And in this case, the short rub dough, short texture means it's more crumbly. We're looking for very tiny pea-sized pieces. For longer rubbed doughs, a longer texture means that we have more flakes there, like in a typical pie crust or a southern biscuit that has all these layers built into it. We're looking for longer, flatter pieces of crust. And then laminated dough is the last dough that uses steam leavening, and that's for things like puff pastries and croissants. So all three of these types of doughs are leavened via steam leavening. And the way that works for these rubbed doughs or laminated dough is that we are taking fat that has water already in it. Now keep in mind that when we talk about butter, we've got 20% water, 80% fat in that butter. Butter is an emulsion. And so that 20% water is in that fat as long as it's cold. Very important to keep things cold here. And what we're doing is sandwiching those fat pieces between dough pieces, okay? And so when that product is heated, that water that's in the fat turns to steam and pushes those two dough pieces apart. And we're going to talk more about this as we move through to next week's lecture as well. But just know that rubbed doughs are steam leavened. Right? So basically, pieces of cold fat surrounded by dough. These short, crumbly textures are like scones or the pâte brise. You can see how tight this is. There's not a whole lot of leavening there, very crumbly. And then biscuits that have all of these layers, or very flaky pie crust where you can see little sheets of dough there. These are going to have longer, flatter pieces. So we'll be looking at that a little bit more. So hopefully this has given you a good idea of the different types of leavening. And for quick bits in particular, we're looking for a tender product. So we don't want a whole lot of mixing to go on there. We just want the bare minimum of mixing to happen. There's lots of different techniques. Be sure to watch these videos on these techniques before Wednesday. I'm hoping to do a couple of things with the lab products in my own kitchen this week and have those videos posted for you so you can see them prior to the Wednesday meeting. So if you have any questions, use that Q&A forum, shoot me an email. I'm happy to address them. And otherwise, I hope you are at home, safe and healthy, and we'll see you on Wednesday.